Welcome to
BAM! Physics! Where we learn about
physics,
and we're going to be doing
velocity and vectors.
v squared.
Yeah.
Alright.
So enjoy our video.
Our pathetic attempt at a video. Don't call it a video.
Don't make fun of us after it's done.
Thank you and good night, good people.
BAM! Physics presents vectors.
That's pathetic.
We
walk 1 meter toward the red pig. Toward the red pig. Right there. Then we walk another 1 meter toward the miniature helicopter. Or full size, whatever you want. Then we walk 6 meters toward the brat stuff. So pathetic. Then, happy birthday bear.
To the happy birthday.
Toward the happy birthday bear. Alright. Then we walk back to where Tom's standing. Say hi, Tom.
How is everybody doing today?
Walking back, and that's what Tom's gonna do. I'm gonna be filming it. And he might kick some of the markers if he wants.
Yeah. Okay, sure. Now I'm going to walk 1 meter north. Now I'm gonna walk 1 meter west. Now I'm gonna walk 6 meters north. Stupid dog. 4 meters east. Now I'm returning to where I started. I think we need to do this again.
The distance from the end point to the start point is 7.62. I'm sorry. And then when we use the Pythagorean theorem, which is a squared plus b squared is equal to c squared, by creating this triangle here. And since this is 1 meter and this is 6 meters, we combine that to make the 7 that we see here. And the 3 meters is over here. And then we squared those, and we got 49 plus 9 is equal to c squared. So radical 58 equals c squared. Radical. Then we get c is equal to 7.62 meters. Oh. Tom. Alright, now Tom's gonna explain what the rest of it, you know.
Yeah, so we found that the total distance I walked was 19.62 meters, and the displacement was 0 because I ended up in the same spot where I started at the end. So
basically he theoretically
went nowhere.
Nowhere. Oh.
Done.
Bam. Vectors.
Okay, so now we're going to do some velocity stuff. I'm going to start at this car, and we used a meter stick to measure out distances of 1 meter.
That's the first meter, right there.
So the pig represents 1 meter, the helicopter is 2, the happy birthday bear is 3, and the brat style is 4 meters. So what we're going to do is Shoba is going to time how long it takes me to get to each spot or distance marker, and then we're going to find out my velocity at each distance and my total velocity.
Bam!
Bam!
Physics! Bam! Velocity.
2.2, 4.2, 6.2, 8.4. So, okay, that's... Oh, no, stop.
Bam! Velocity.
So, velocity is v equals distance over time. So, we created a distance and time chart to record our data. Like we said before, we placed the toys at different distance intervals. They increase by 1 meter each time, so that's why we have 1 meter to 4 meters on this side. And then we recorded how much time it took me to get to each interval on this side. The time increases at each interval by about seconds, which is supposed to happen because we were trying to remain at a constant velocity. But it goes to 8.4 at the end and increases by 2.2 because I accelerated by accident at the end. The graph over here is a velocity graph. It's distance over time because velocity is distance divided by time. So we plotted each point that we found on the chart and then did a line of best fit and tried to include as many points as possible. Then down here we found the different velocities. So at 1 meter it was 0.45 meters per second. At 2 meters it was 0.48. At 3 it was 0.48, and at 4 it was 0.48. So the average velocity was 0.48 meters per second.
So bam, velocity.
Bam!
Hope you enjoyed our video.
And we hope you learned a lot, even though you probably already knew all the stuff we went over.
Well, we didn't know it, so it was beneficial to us. So
Yeah, I know some physics now.
so bam, physics.
Yeah.
Yeah, man.